guys again, unit circle, unit circle, unit circle. Do you think it's a big deal? Yes, it is a very big deal. You definitely need to know that in calculus, just FYI. Actually, for all your maths, and even when you go to physics. Okay, I'm getting on my little soapbox, but anyway, you definitely need to know it. Now, I want to look at number 40, because 40 is one that I think we oftentimes race through, especially in pre-cal or maybe even algebra 2, and it's definitely worth kind of getting a handle on, because this is money, and we need to know money. It's very important to know some money. So it says, how long will it take for prices in the economy to double at a 14% annual inflation rate? For starters, that's a huge annual inflation rate, but hey, whatever. So if we're looking for it to double, remember that simple interest stuff, right? The simple interest. You know, you have the sum A is equal to P, 1 plus R to the T power, right? That's just our little simple interest stuff. So if I'm sitting there saying, okay, well, I want my money to double, so I wanted twice my rate, twice the principal. The rate was 0.14, and then, of course, we're solving for T. So you might think to yourself, wait a minute, we have two variables. But we actually don't, because when you divide by when you divide by P, then you're just left with 2. Oh, look, Christmas colors, that's fun. So anyway, so now when you redo this, when you're going to solve that, remember, whenever you're trying to get a variable out of the power, you have to do a logarithm. So this becomes the log of 2 base 1.14. Remember, 1.14 is the base of the power, of the exponent. It's also the base of the logarithm. Let's not forget that. 41, I am sure you already remember the formula, because I am sure you remembered it from pre-cal days. And then you just plug stuff in. Just take note, N is 4, because it's compounded quarterly. Fair enough. And then, of course, you're trying to triple, so instead of A, it's going to be 3P. Hope that makes sense, and then you can figure out what the answer is. Alright, so this page just has a bunch of those more pre-cal things. And I think these two word problems are pretty straightforward. I don't think you're going to have a problem kicking those guys out. This number here, 44, it's not very difficult, but there's just a few things I want to make sure you remember when you're talking about inverses. So the inverse, of course, you know how to find the inverse. We already talked about that in a previous problem. But one thing I want you to note is that the domain they gave me is x is greater than or equal to 4. Of course, we knew that. But please note the range is greater than or equal to 0. I tell you that because that range becomes the domain of the inverse. So now, to find the inverse, interchange the x and y, solve for the new y. You've seen that, right? Square both sides. Look how much fun we're having, right? Slide that over, and you get x squared plus 4, which you would think is just a good old-fashioned U shape. But remember, this range becomes the domain, just like this domain becomes the range. And that's huge when you're dealing with inverses. So that's why the answer ends up being the one that deals with x squared plus 4, but it also puts that stipulation that the domain is x is greater than or equal to 0. And it's all because when you have a function and you find its inverse, everything flip-flops. Domain and range flip-flop, just like the x and y's flip-flop. So just take note of that. Alright, we got some logarithm things. Those aren't so bad, I hope. Definitely want to make sure you know how to do your logarithms and simplifying. I am actually going to do this problem because I think it involves a couple pretty cool steps. Of course, every math step is cool, in case you're wondering. Alright, so here we go. So we have ln of y minus 34 equals 2x, right? So I'm going to e both sides. When I bring in an e to both sides, I get y minus 34 equals e to the 2x. So y is equal to e to the 2x plus 34. So I thought that was kind of fun. Bringing in the e, kind of exciting. I know. Look, pulse race. Yep, yahoo. All right. 30 is pretty clever too. So when you do that one, definitely show your work for that guy. All right. Look at the next page. All right. So these problems again, 52, 53, and 54, very, very fun, of course. 53 is pretty daggone fun. I'm not gonna lie. So ln of y minus 8 minus, I think it says ln of 7 equals x plus ln of x. The key with this problem, man, that looks sloppy. The key with this problem is rewriting x as an ln. The ln of y minus 8, he's okay. Minus the ln of 7. X, though, is the natural log of e to the x. The reason why you have to do that is because you're trying to get y by itself. Well, in order to get y by itself, you need all these guys to become one term. So, just a little hint, that's what you need to do. And then when you work it out, you bring over the ln. So I get ln of y minus 8 equals ln, and think about this becomes 7x e to the x. And the reason why is because when I add ln of 7 to the other side, I have the ln of e to the x plus the ln of x plus the ln of 7. Well, just like I knew, when you have addition between logarithms, you end up having the logarithm of the product. And that's where that came from. Now, when you kick this guy out, you're like, okay, well, ln of something equals the ln of something. Those somethings better be equal. Well, now you're just home free, aren't you? Plus 8. Look at that. Isn't that fun? I know. Exciting. All right. And then, of course, 54, no-brainer. 55, 56, unit circle, unit circle, unit circle. Don't forget. All right. And then 57 and 58, you kind of have to think about them a little bit. So 57 is sitting there saying, okay, consider the graph f of x equals 4. Here, I'll go to another page to make it a little bit cleaner. Sound good. There we go. It's not like I have to read it to you, but, Anyway, it says 4 minus x squared. And it's going from 0 to 1, right? Well, just remember, if the domain is going from 0 to 1, then the range, 0 is the smallest value plug in, you end up getting a 2. 1's the next value plug in, you end up getting a square root of 3. So the range goes from square root of 3 to 2. So just remember, domain 0 to 1, range goes from square root of 3 to 2. Now, they're asking you, what symmetry does it have? Well, when you graph it, remember, you're dealing with part of a circle, okay? So when you do end up graphing this thing, you end up getting, the graph has symmetry over the y equals x line, all right? So it does have symmetry with the y equals x line because it's a circle, and it's literally coming straight through. The y equals x line is just coming straight through. And you're going to have that symmetry. And then, when you go and find the inverse, it's its own inverse. Because the semicircle is its own inverse in quadrant 1. Because it literally just flips it. So, D ends up being your answer for that guy. And then with 58, it says if f of x is 1 to 1, so you know it has a function, passes a horizontal line test, all that good stuff. Then it's saying g of x is equal to f of negative x. Is that also 1 to 1? Well, think about this. If g of x equals f of negative x, that means you've got symmetry over the y-axis. Because that's what symmetry over the y-axis means. F of x equals f of negative x. So we got the symmetry over the y-axis, which means it also must be 1 to 1. Because if f of x is 1 to 1, and you reflect that over the y-axis for the new function, well, that has to also be 1 to 1. So that's why the answer to this one is C. Cool? All right. So I hope that clears up some questions that maybe you might have had on this worksheet. I really hope you didn't have too many questions. If you got any of those ones wrong with the unit circle, then you're just not, you need to know the unit circle. There will be times when you don't want to slow it down, or you won't be able to use a calculator on that part, and blah, blah, blah. Just get to know that first quadrant, and then just walk it around. So just kind of a quick little tad bit in case you haven't seen that video yet. Just kind of remember, when I'm dealing with a unit circle, right? If you know your quadrant 1, your life becomes so much better, right? So remember, this point here, He is my radical 3, comma, over 2, comma, 1/2. This point is, stripped, radical 2, and this one over here is, of course, 1/2 square roots of 3 over 2. This ordered pair here is 1, 0, and this ordered pair up here is 0, negative 1. Please, 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 please note, right? 0, pi over 6, pi over 4, pi over 3, oops, not 4, pi over 3, I'll be okay, and then pi over 2, right? You're dealing with a long on the x, short on the y. But for the 60-degree one, it's long on the y, short on the x. That's why these guys are flip-flopped. Alright? Because it's a short trip on the x, and it takes forever going up on the y. This other one is a longer trip on the x, and a shorter trip on the y. Pi over 4 gets me the radical 2 over 2's. If you don't know that, I'm sad. And then, of course, these numbers, these points over here, I mean, they're on a unit circle with a radius of 1. So, of course, the ordered pair has to be 1, comma, 0. And then over here, you've gone, oh, that's a positive 1. Look, I'm messing it up already. Sorry about that. So, of course, the point up here is 0, 1. Over here, negative 1, 0. And then, of course, down here, 0, negative 1. And then, remember, 6 goes into 180 30 times. So that reference angle is 30 degrees. 4 into 180, 45. 3 into 180 is 60. So that's how those angles go with those radians. I hope that helps. I hope you